I know what you're talking about. Yeah, you're still a ways away. And the moon's not going to come up until about 10.
That's good because I
You're gonna
plan
need
to
it.
be there and take my time taking shots. And then if the moon comes up and I can see it, I planned on catching that moonrise too. But that's kind of a secondary target.
And
I think
Charlie,
I'll have a
while I'm thinking about it, Kevin Daney asked me to remind everybody that this is the 20th anniversary of the Great Lakes Stargaze this September.
Wow.
What's
So
the dates for September?
it's going to be late in the month, I think like the 25th or something. That's
6
towards the
and
last
7,
weekend.
I think, isn't it?
It's towards the end of September.
End of September?
New moon weekend, so it'll be the 20th anniversary of the Great Lakes Stargaze.
Yeah, it'll be near the end of September. Yeah. By the way, Adrian,
Right.
moon comes up at 9:23 tonight. Sorry.
That would be like September
Yeah.
24th,
Yep,
23rd, 24th.
yep, that's the weekend.
Okay.
I'm
Got it
going
right
up
here.
there the whole week.
And that's the
Yeah.
weekend. That's the weekend after astronomy at the beach.
Yes.
Yeah, we picked astronomy at
Yeah.
the beach the weekend before because we knew if there's going to be observing, that's where people will go. Of course, that's the same time as Okie-Tex, right, Jim?
Yes.
So some of us are not going to be at the Great Lakes Stargaze this time. And just to let you know, Doug, I will likely be taking a new, smaller equatorial mount.
Yeah. No, I
don't
heard.
know
I
that
heard. I heard.
Okay, you were there.
Yeah.
Yeah, so you're on your own with the G11.
Hey, that's fine. I actually had my other tripod and wide field camera up there for time lapse anyway, so I would have done that. I would have done some 300 millimeter stuff with my Ioptron tracker if I hadn't gotten the
Yeah.
G11 going. So I
That's
wasn't
cool.
I wasn't totally out of luck there.
True. But the Iris Nebula that you caught was pretty amazing. So it's worth helping out. You actually had you were able to get a lot of data, probably less time than it would normally take in your regular observatory.
Yeah.
Those images came out very well.
Well, yeah, that happens when you get 6 clear nights in a row, as opposed to taking 2 months to get 6 clear nights.
Well, not only that,
Who do
but
you have to rate
Portal
that
1,
with?
so
Okay.
Portal 1, so it doesn't take as long for the data to get down there either.
Yeah, well, I
It's
was
like having a
taking.
ginormous pipe and a lot of time.
I was taking. Yeah, I was able to take 10-minute subs easily without any sky glow.
That's nice.
I'm going
Okay,
after
I
some
was-
type of fairly large nebula tonight, but it's very diffuse, so I'm not sure how. IC 405, which is called the Flame Star Nebula.
May have seen that once or twice in a while. And by the way, Charlie, if you want to go ahead and officially get us started, because it's 7:40.
It is. Yep.
Oh, that's right. I know you wanted to wait a little longer, but we
No,
can
I was
let
going to
you
go
get
ahead and start at 7:40.
Yeah.
And meanwhile, Jeff did get a response.
Okay.
Well, explain that. I'm not sure I understand that, Jeff.
Well, back in January, I got a January 4th. I responded to him and he responded back saying, sounds great. No questions about YouTube or the Zoom stuff. And then
Oh,
Charlie
right.
got a response back on what gift he would want and all that kind of thing. So,
Yeah,
but that was January
We
4th
did.
and 5th. So,
we did give him the right date, didn't we?
well, that's worth checking.
Yeah, you never know.
We did say 2022, right?
That's another thing
Hopefully.
might be worth checking. Yeah.
Oh, let's see. Where is it?
Next January, we got Brother Guy back, by the way.
First
Is he
May.
gonna be in town or is it a Zoom meeting?
We selected that because he's hoping to be in person.
Good. That'll be good.
That'll be cool.
Yep.
Is the speaker by chance in another time zone?
He's in Mountain Time, Boulder, Colorado.
Oh,
About the time we're all
Yeah.
in bed, he'll call.
But
Oh,
Dan
but-
Durda is a former Lowbrow president. So, he's from the area and stuff. He's aware of the time.
Yeah, he's also
yeah,
in the
21st.
universe today Rockstar Astronomer, you can watch some old episodes and you'll see him on TV.
Yeah. So I got to believe something has come up on his end to the point that he can't even contact us at the moment. So,
Right, to let us know.
yeah, because I would think
And
if
I
he's
was-
having trouble getting in, he would have at least emailed us. Let me just check my email again, and nope, nothing from him yet.
Yeah,
Does
you
anybody
forgot-
have it? Anybody?
Got Lowbrow as a password.
No, I looked. I was thinking I did have a phone number for him, but I don't. I'm going to get one now.
Yeah.
It doesn't help us at the moment, so. Yeah, I usually try to get that from speakers, but
The passcode I do pass on to all the speakers. I give them basically a full invitation with the URL, the passcode, the phone numbers, all that other stuff.
right.
Yeah.
So, and he acknowledged it, so like, okay.
Yeah, so we'll just have to wait and find out what,
Something-
yeah,
something
what
to
went
be up.
wrong on his end, so.
Find out.
So
All
meanwhile,
right, Charlie.
everybody has found their way into the January edition of our Lowbrow meeting. I think everybody knows who I am, so I won't explain that. I can't explain that anyway. Uh, So I will go ahead and get started. Also, just a reminder that we are not recording on YouTube, but we are recording the meeting. We'll upload the YouTube later. So
Yep.
as far as business things, the only thing I had was two things. Right after I had sent out the notice that the meeting was going to be just Zoom only this time, I got an email from Shannon Murphy announcing that the U of M had just reserved G115 for us for the quarter, which I think is January, February, March. So I guess we're just going to take it month by month. We've got the room apparently. So as we approach the next meeting, we'll just have to make a decision if we want to do another hybrid, or hopefully the COVID situation will be better than it is now. So anyway, that's an option. We'll just have to see how that goes. And also I got an email, which I haven't even got time to respond to yet, from a person up at Promain Library, which is right next door to you, Doug, pretty much. And they're requesting that we do some kind of an event for them sometime during March. They actually had put a request in last year, and we were set to do something in the summer, I believe it was. And they were supposed to contact me so we could show that, hey, there's Dan.
Hi, Charlie.
I kind of thought I saw something new there. I just didn't see the name yet.
Sorry, my apologies for being late. A couple things going on here. I just got tangled up in.
That's
Gotcha.
okay, Dan. We're glad to see you.
Absolutely, better late
How y'all
than
doing?
never. So I'll tell you what, I'm going to come back to Cromain
Thanks.
Library when we get back to our business meeting. And meanwhile, we'll go with our traditional format, and that is to have our guest speaker speak to us first. And as you know, that is Dan Durda. And let me just pull up his.
Yeah, and sorry I'm late, so I didn't have a chance to practice and sharing screen and all that sort of thing. So if I have any little bugs, we're just gonna go with it and see what happens. But
Quite all right.
hopefully the share screen will work.
We'll work through with you.
So,
Dan.
so Dan Durda has more than 25 years of experience researching the collisional and dynamical evolution of main belt and near Earth asteroids, volcanoids, Kuiper belt comets, and interplanetary dust. His research interests include numerical modeling of the formation of asteroid satellites and observational searches for them, studies of crater ejecta generation and redistribution on asteroids, the environmental effects of asteroid and comet impacts on Earth, and airborne astronomical observations from high-performance jet aircraft. Dan has extensive experimental experience in hypervelocity impact studies. He's an active pilot with time logged in over a dozen types of aircraft, including the F-18 and the F-104 Starfighter, and has spent over 110 minutes of time in zero gravity conducting experiments on NASA's KC-135 reduced gravity research aircraft. Actually, Dan, isn't that the one they nicknamed the Vomit Comet?
Yeah, for good reason. Yes.
Yeah, I thought it was.
I'll tell you a story about that later on.
Oh, cool.
Remind me to tell you that.
Okay, I'll try to remember. A finalist in the 2004 NASA astronaut selection, Durda is one of 3 Southwest Research Institute payload specialists who will fly on multiple suborbital space flights with Virgin Galactic and Blue Origin. He serves on the board of the B612 Foundation, served as a member of the Commercial Spaceflight Federation Suborbital Applications Research Group from 2008 to 2017, and served for over 15 years as the program coordinator for the Planetary Society's Gene Shoemaker Near-Earth Object Grant Program. He has co-authored a book, published numerous articles popularizing planetary science and human exploration of space, and has appeared in over 70 nationally broadcast television science documentaries, which I'm sure is over that number now since I wrote this intro in 2019. Dan is the 2015 recipient of the AASDPS Carl Sagan Medal for Excellence in Public Communication and Planetary Science. He is a fellow and former member of the board of directors of the International Association of Astronomical Artists. His space art has appeared in many magazines and books and has been internationally exhibited. Dr. Durda is an experienced cave diver and holds multiple scuba and cave diving certifications, including full cave and cave recovery specialist. Until recently, he served as the Colorado and Arizona regional coordinator for the International Underwater Cave Rescue and Recovery Team. So as you can see, Dan does a lot of stuff and has been everywhere. He's goes low and he goes high. So, and if that's also not enough, Dan is also a former Lowbrow president. This was back in the 80s. So that means he was also one of our very earliest club members. And he hails now from
the Detroit Observatory.
Pardon me?
Back when we held the meetings at the Detroit Observatory.
Yep.
Yeah. And as it turns out, actually, there is a chance that in the future here we're going to return there. So
that's great. It's a great site. I love that building.
Yeah. So that's kind of a work in progress, but that could happen. So anyway, with that, I will turn it over to our guest speaker, Dan Durda.
Awesome. Thanks, Charlie. And great to see you all again. Enjoyed my trip there in person, I guess, a year and a half ago, something of that order. That was a lot of fun. Good to see familiar faces again and be back home. Let me go ahead. Like I said, I didn't get a chance to really practice here too much in terms of sharing screen on the technical side, but let's see if this will work. Okay, what are you guys seeing? Do you see my slide? You got it? Okay.
Looks good.
Yeah.
Now we can see if I can drag my other, why is it not wanting to bring that over? Well, I'm sharing that, but now it's not letting me actually see my own. Well, I guess I can drive it this way. You seen the Wright brothers?
Yep.
Yeah.
Okay, good. So I guess that's all working. That'll work well. So yeah, last time I talked about asteroids and some of my asteroid research and the science side of things, offered Charlie a couple of options for this meeting tonight, and we settled on some of the new stuff, the current stuff that I'm working on primarily with Alan Stern here at Southwest Research, the same Alan Stern as the New Horizons Project and so on. When Alan hired me on here back in 1998, it took a lot of effort for him to get me here. I was happily ensconced in Tucson in Arizona at the Lunar and Planetary Lab doing all my asteroid stuff, and Alan was after me for a little while. He was building up this group here at Southwest in Boulder, and we had hit it off years before when I had met him in University of Florida. He came through interviewing, and we kind of hit it off, and I think he felt that it was a good fit for the program and all. It took him a lot of effort to get me to finally come here because I was so happy in Tucson, but one of the things he offered, he kind of dangled the keys of an F-18 in front of me and said, if you hire on, we're going to be going fly F-18s and doing astronomy from the back seat. And I was like, well, okay, I think you finally did it. That's the one thing that's going to get me to leave is my chance to finally get to go and fly those high performance jets. So that's a little bit more on that later, but that's what basically led us. That was the entree for us here at Southwest into our into suborbital space. Before commercial suborbital became a thing, I think Alan was recognizing that it was coming. He was watching what Burt Rutan was doing out at Mojave, and kind of saw it becoming a thing. And I think he had the astronomy from the backseat of jets kind of in the hopper as an entree to that. So I think that rang a bell with me in terms of fun things that you guys might like to hear about a little bit. So I thought I'd talk about that tonight. So and it really, what we're going through today with suborbital is a lot like the beginning of flight. Back in 1903, the first flight with the Wright brothers. By 1910, October 11th of 1910, Teddy Roosevelt got to be the first president ever to fly in an aircraft. Already just 7 years after the very, very first flight ever happened, the president was flying. By the 19-teens, children were flying an aircraft with barnstormers. By the 1920s, the first airlines had formed, and people were starting to actually go and take vacations on aircraft. And the whole industry had formed just a decade or two after the very, very first flight. In space flight, we're going on 60 years into it already almost, and we haven't even really gotten to the barnstorming stage yet. I guess we're just starting to get to the barnstorming stage. And that's really changing. It's about to change. It's changing now. And I think we've seen it with the Inspiration 4 flight, SpaceX, the first all civilian crew. We've seen it now with the first commercial flights, first human payload flights with both Virgin Galactic and Blue Origin. And so we've gotten in on this game, and got tickets to fly. Like I said, it really kind of started back in 2004 with the Ansari X Prize. This was a couple of folks had the idea that, again, kind of harkening back to the aviation world, that a lot of progress was made in the early days of aviation by offering prizes, incentives to push the boundaries and develop the technologies and develop the capabilities. The whole, Lindbergh's flight across the ocean, right? That was a prize. He wasn't guaranteed to have won that. In fact, other people had set out kind of pretty much at the same time to try to do that and failed. So a lot of prizes offer really good incentives. And so the X Prize was basically, $25 million for the first team that could develop a suborbital vehicle that could fly up above 328,000 feet, come back, and then within a week reuse that same vehicle and do it again. If you could do that and demonstrate it for real, not just on paper, actually go and do it, $25 million was yours. And I think Burt Rutan was very well prepared to do this. I think even before the prize was offered, he was already working on the idea for what was Spaceship One at the time. And so it turned out to be a relatively easy win for him. There were other competitors trying to play the game, but they just weren't quite as far along. Rutan being the aviation design genius that he is. And it was a pretty easy win. And right at that same time, obviously, as they were winning, Burt Rutan was, Richard Branson was eyeballing the capability. He had already registered the company name Virgin Galactic actually years before. He had a vision at one point of this sort of space tourism, and had registered the name very, very early on. And so when Rutan came along with Spaceship One, I think that's the moment that Branson was sort of primed to say, okay, I'm going to buy into that. I would like to license and buy your flight and launch capability, and we'll buy it and operate it under Virgin, under the Virgin Group. And that was the birth of Virgin Galactic. And Spaceship Two is now Spaceship One was the test vehicle. Actually, Alan and I we sat across the table. We had a meeting with Burt back in 2004, just like a week or two after they had won the X Prize. Alan and I went out there and met with Burt, and really sort of, I don't even want to say inked the deal because there was no ink involved. It was a handshake across the table. The idea back then was after they won the X Prize with Spaceship One, they were going to fly the vehicle 10 more times on 10 more missions to round out, sort of push the boundaries of the flight envelope, learn a little bit more about how the vehicle operated, and use that as real world working knowledge of how to improve the system and build it bigger and better for what was going to be Spaceship Two, the capability that Branson wanted to buy into. But then Paul Allen, who had actually footed a lot of the bill to build Spaceship One, said, no, you've won the X Prize. I want that vehicle in the Smithsonian. I don't want to take the chance of losing it during a test flight. And so with that, Alan and I lost our space flight way back in 2004. But Spaceship Two has now flown. Richard himself has flown. People I know have flown. It's really fun to get to see folks actually getting up there and doing things. Not far up the coast, up in Kent, Washington, is Blue Origin, Jeff Bezos's company. Every time you're buying an Amazon product and having it shipped to you, you're funding a space program. And it's not just suborbital. Blue Origin is into the business of orbital space and some other things at the moment too. So, but this is also not a paper project. This is, as you've seen with William Shatner flying and other folks, this is the real deal too. And real people, everyday people going up to space, and it's happening. It's amazing. It really is the sort of the Alan Shepard special. New Shepard was named for Alan Shepard, and it's basically reproducing this whole idea of commercial suborbital flight is reproducing the very first space flight that America did, which is a suborbital flight up above the Kármán line, up above 328,000 feet, 100 kilometers, the internationally recognized boundary of space. It's a ballistic flight up. You're rocketed up at, I don't know, about Mach 3.5, something like that, and bounce up above the Kármán line. 3 or 4 minutes of zero-G over the top. Beautiful view of the curvature of the Earth, the thin little blue ribbon of our atmosphere, black, inky black space above, and then you begin your fall back down into the atmosphere and pretty much landing where you took off from. A little bit different in both cases, both for Virgin and Blue Origin. Virgin's a winged aircraft that's going to glide back and land where it from the same runway that the carrier aircraft took off from. In the case of Blue Origin, it's your traditional space capsule that goes up and comes down, and parachute landing back in the desert right there at the launch site in West Texas. So that's the basic game there. Back in 2004, when this was all sort of proposed, it was tourism. They envisioned this as the same people who are going to pay a lot of money to go and climb Mount Everest, the adventure tourist. Those same folks are going to be the folks paving the way and buying those initial tickets for that once in a lifetime, trip that we've all dreamed of, heading up and seeing the planet from above. That was the basic idea, and that's where most of the drive was. But and it's great. It's opening up spaceflight to everybody. A very much different face of spaceflight today than it was back in the 60s and 70s and 80s that we knew, right? The sort of the healthy, fit military test pilot type person, and you get the same perspective over and over from them. The right stuff kind of perspective. But when grandma down the street and the artist next door is flying, you're getting a different story of what space flight means and a different connection to what it's like to see the planet. And I think that's going to be, it is already, and I think it's going to be a great thing. I think when you go back and watch some of the interviews with both, with both Bill Shatner and Michael Strahan, the Good Morning America host who flew, they both are telling it in ways that I've not heard many professional astronauts be able to express, and it's that's what it's all about. But very early on, Alan primarily recognized that, by 10 years later, we were already thinking of it more in terms of research, because you know, a tourist may buy this once in a lifetime flight once, and you've sold one ticket, and now that person is done flying. You've sold that one ticket. When a university buys tickets, or a research corporation, a commercial entity is buying tickets, they're buying multiple tickets to go and develop a capability, to do an experiment, to develop a product. They're going to be buying multiple tickets, and potentially the market for those flights is a lot bigger from the research side of things. And I think we recognized that pretty early on, and that's where we decided to focus our energies. It's not just about going and having fun. Of course, it's going to be, you know, an amazing thing we've all looked forward to, but it's about getting us as, you know, researchers into the field the way marine geologists and marine biologists and pretty much any other sort of field scientist has been doing all along. And this is finally our chance to get to our laboratory, if you will, in person, because nobody's gonna do your experiment better than you are. And so that's what this is really all about. And the key that this offers is frequent, low-cost access to space. It's been so expensive and so difficult to get payloads up there, and almost nigh impossible for the experimenter themselves to get up there to do the experiment. And that's what the key is here. And so this is our team. Myself, Alan Stern, Kathy Olkin, who is another experienced flyer here at Southwest. She's a principal investigator for missions. She's flown on Sophia, the infrared astronomy aircraft, a lot of experience flying as well. And that's our core team. And we're getting ready to fly. I'm going to show you a few things here. We've, as an institute, have already invested well over $1 million toward this, buying the tickets, buying the capabilities, building up our experiments. And the idea was to basically put us at the forefront at Southwest, to give us a little bit of an upper edge from a research grants proposals perspective in this community. So we developed a couple of different payloads. We've already bought our services with Virgin Galactic. We're in discussions with Blue. They're not quite ready to be flying people yet with experiments. They're flying people, but not people with experiments yet. They don't have that capability with their cockpit quite yet, but we're in discussions with them about it, and getting ourselves all trained. The 3 experiments we're going to be flying initially, and I'll tell you a little bit more about that in just a second, how that's going to work. But one experiment is just going to be us, just wiring our own bodies up with biomedical harnesses to measure things like heart rate and blood pressure, and just getting that initial response of the human body in that flight environment. As strange as it may seem, this is not something that's been able to have been done very much yet in professional space flight, in NASA astronaut space flight. You know, the astronauts are very busy when they get to orbit, and they're going about other things. There's been a few pilot programs of putting bioharnesses on folks, but there's not a lot of data yet on the immediate response of the human body within those first few minutes of getting into weightlessness. And now that, you know, hundreds and coming up soon, thousands of people are going to be flying, of all different demographic backgrounds and body builds and body types and medical histories. Like I said, it's not going to just be that, you know, incredibly fit, you know, military test pilot type profile. It's going to be people with chronic problems and other issues, and that's going to provide the people who are very interested in human physiology a very much broader database. So we're advocating that anybody who gets to go fly ought to think about, you know, wiring themselves up and you know, providing data to the people who are interested in it. We're all potential subjects that could be very valuable to our colleagues who are interested in human physiology. And we've already done this. We've you know, been wearing these things. You see a picture there of Alan. We're all wired up to go fly in the F-104, and there's bits and pieces of the bioharness hanging out of his suit there. He's basically measuring heart rate and blood pressure during the flight itself. And I did that twice, and you're so busy doing the other things you're doing in the cockpit, you don't even remember that the blood pressure cuff was going off and stuff like that. So it works pretty well. The other experiment is our the Southwest ultraviolet imaging system, basically our telescope in the back seat. This is what Alan hired me on for in the first place at Southwest, which was operating this system in the back seat of the F-18s out at NASA Dryden. And this is the same imager that we're going to be flying on Virgin Galactic soon. Back then, I was using it to observe occultations, asteroid occultations. In fact, I think there was an occultation in 1999, 308 Polyxo, the asteroid 308 Polyxo. When you look at you've seen probably those little maps of the chords across the asteroid surface. Every different location that you can potentially observe the shadow passing across. Measures a little chord across the asteroid. That's how we can actually measure the size and in fact shape of something that's only a point source in a telescope. But if you position enough observers across the ground where the shadow is sweeping over and time things very carefully, you can get some information on the size and shape. If you look at the map of the chords for 308 Polyxo event back in 1999, there's all these nice parallel chords, except for one that's on a cockeyed angle. That was me in the F-18, because the F-18 was moving during the observation, and so our start time and end time were taken at two different locations, and so that angled the chord a little bit relative to everybody else. But it was really cool because down below us it was cloudy, so I got to do the observation. But it was pretty much the point of the demonstration project, was showing that this was a capability for getting high priority events like this from more mobile aircraft than something like the Kuiper Airborne Observatory or Sophia or something like that. If you can base this in an aircraft that can pretty much take off anywhere and fly over water and things like that, or bad weather, you can get data on high priority events like this. So we're going to be flying that same equipment on Spaceship Two. And then so that's basically demonstrating that you can do out the window astronomy and out the window observations of the Earth and things like that from these vehicles. That's a particularly valuable thing about them, is that they're putting you above the atmosphere. The other obvious environmental benefit of these things is they're putting you in the microgravity environment. You can do parabolic aircraft flights that we've talked about, the vomit comet, if you will. But there you're getting 23 seconds of weightlessness. What can you do in 23 seconds, right? Quite a lot, it turns out, which is why so many people fly those parabolic aircraft for research. But when you are getting 3 and 4 minutes of microgravity, and it's 10 times cleaner microgravity than what you're getting on those aircraft. By cleaner, I mean you're just not getting any of the the atmospheric buffeting and things like that. There's a lot of capabilities that you can have that you don't get in any other way other than actually going to orbital space, which is very expensive. And so we're going to be demonstrating the capabilities of the microgravity options of these vehicles by doing my box of rocks experiment, basically. I'm an asteroid guy, as we know, and so I'm interested in the regolith of these little things. We already flew a Pathfinder of our box of rocks experiment with Blue Origin back in 2016. And then we repeated that with a much higher fidelity experiment, Bohr 2, in October 2020. The idea here was demonstrating that you can do magnetic collection of regolith of asteroids. Most asteroids, almost all of them, have some amount of free nickel and iron in the mineral structures that allow you to just pick up regolith with a magnet. You don't have to drill. You just go there, you stick a magnet, and you collect the stuff, and you bring it back. And we demonstrated that with Bohr 2. I think I may have a movie here that may play if I can make it play. Let me see. If not, I will find the movie. Oh, it's not going to play. Oh, well. I'll go back and I'll find the movie and I'll play it. We'll come back after. It was really neat to watch we had these little tetrahedra, these little, you can see the size of these things in my hand down here. The idea was inspired by starfish, basically, which kind of invert their stomach out into the world, envelop it around what they want to eat, and then they pull their stomach back in. The idea here was, if we can land these little mini tetrahedra on the surface of an asteroid, let them with magnetic petals, if you will, to these little flowers that will open up, let these things bounce around, collect material on the outside, those petals, and then open up those little tetrahedra and invert them so the outside becomes the inside, you've now trapped your sample on the inside of this little tetrahedra to then be later collected by the mother spacecraft. And it worked beautifully. We had just absolutely 100% beautiful success with them. So I'm starting to wonder here that any of my movies are not going to play. Yeah. Oh well, that's okay. I'll go back and we'll play the movies after, and I'll show you a little bit more about them. I know I came in late, so I wanted to offer you guys the chance to ask some questions now while I'm going to go back and find the movies. So let me go back to a previous version of another talk where I had them hidden away. And go ahead and ask anything you want as I'm trying to find some movies.
Dan, I have a question for you, Norbert Vance.
Hey.
You haven't seen you in a while. It's good to see you.
You too. Thanks.
Yeah. I have a friend, a former student of ours from Eastern that worked in Cassini for SWRI, Greg Fletcher. Have you crossed paths with him by chance?
Not up here. He might be down at the San Antonio office.
That's where he's at.
Yeah. Okay. That's why. Yep.
Yeah. Okay. I'm just curious because he's been deeply involved with Cassini and was, I guess, instrumental, if not the one that sent the spacecraft through the plumes of Enceladus.
Oh yeah, it was amazing stuff. I mean, it's yeah, just absolutely revolutionized our view of that moon. I mean, Voyager gave us some hints. I think the hints were already there from the E-ring if we were ready to read them correctly. I think some people even sort of made some generic predictions that somehow the material from the E-ring was coming out of Enceladus or off of Enceladus in some way, but I don't think anybody quite imagined the tiger stripes and the geysers the way they ended up being.
Yeah, SWRI is one of those quiet companies that you don't hear about too often, and don't realize that they're doing such terrific stuff.
Yeah, it's a fun place to be.
JPL or John Hopkins, but that's cool. Very good.
Yeah. Well, we partner with them a lot too, right? Obviously, like for instance, New Horizons, which maybe it wasn't such a quite quiet mission because Alan, I think, did a pretty extraordinary job of making sure people heard about it. But yeah, we partnered with APL in that case, for instance. They built the spacecraft out there.
Very good.
Yeah. Let me go back and tell that vomit comet story a little bit here. It's I'm going to stop sharing the screen here so I can come back. I'll figure that out later on. I can figure out how to stop sharing the screen here. Stop share. Okay, there I am. I'm back. We'll try to do that later. Yeah. So the NASA back in the 50s, 60s, 70s flew various KC-135s. There wasn't just one. I think there were up to 5 KC-135s that they sequentially flew. Each one called the Vomit Comet, basically. It gained that name, obviously, because the parabolas that you're flying are somewhat provocative from a motion sickness perspective for people who are sensitive to such things. And it gained that name, basically. I'm now a coach with ZeroG Corp. NASA no longer flies their own ZeroG parabolic aircraft. They contract out to a commercial company called ZeroG Corporation, and anybody can buy a ticket to go fly on ZeroG. You don't have to be a researcher. You don't have to have a grant. You can just say, hey, I want to go fly, and buy the ticket and go fly. And I'm a coach with them now, helping people enjoy that flight or getting the most out of their research flight if they're doing a research flight. And recently we had a team led by a person out at NASA Ames in California. They came out and did a flight. I was coaching that particular team, and they all did a great job. It was this, I can't tell you too much about the experiment itself. It was basically they were making liquid lenses. They were using liquids formed acoustically into different shapes and using that to generate images, basically. But after one of the flights, one of the people of the team was talking to the lead of the ZeroG research program. She was asking, so how did it go? Did you guys have a good flight? Did it, did you get good data? Which is, the primary thing we're interested in. And the gentleman from that team, it was really funny to hear him respond to her. Basically, it's like, oh yeah, we got fantastic data. It was very successful. I really appreciate, you all helping us out through this, and I never want to see you again. He was one of the ones who didn't do so well from a motion sickness perspective during the flight. So. I'm going to continue looking here to see if I can find the movies I wanted to show you. So I'm just going to go.
Hey, Dan, show me your notes. Look, worship. How much ZeroG time will you have? Do you have both on the Vomit Comet and in the suborbital flights to do your science?
Yeah, and I have to tell you, I have to admit to you, I've lost track. I think I've got probably getting close to 2.5 or 3 hours of continuous ZeroG time now, something like that. It's hundreds and hundreds of parabolas, but I've lost track. I fly so many flights now that I've kind of, in the early days, I was every single flight I would log carefully and remember what the numbers were, and I've kind of lost track now. But it's gotten to the point. I have to tell you, it's for me, it's a somewhat different experience in terms of not getting sick. I've been aware, but I've never actually gotten sick on a flight, and so it doesn't quite, the Vomit Comet moniker doesn't quite hold up for me, but it's an amazing, almost undescribable feeling, what it's like to be in ZeroG. It's not like scuba diving. I mean, people try to liken it to scuba diving because you're scuba diving, you're neutral, you're floating, you can move from point A to point B in 3 dimensions and kind of just hang there and float there and all. But even that, though, even though you're neutrally buoyant, you've still got a gravity vector inside your body pulling on things, and it's a very free experience floating in the water like that. If you've done it, it feels great. But it's quite the same as ZeroG. ZeroG is even more relaxing, if you will, when you let all the muscle tension off. I highly encourage you to do it at some point. It's an amazing thing. What we've got at where we currently are with the program at Southwest is last year, NASA for the first time allowed researchers. So let's back up a little bit. For several years, NASA was embracing commercial suborbital flight as a research capability for payloads. They certainly recognized that, yes, it's a stepping stone to orbital flight. It's practice for the International Space Station. By the time you're going to spend millions of dollars building a payload, and you get your one chance in a very expensive, not only from a monetary perspective, but from an astronaut crew, experimenter perspective, it's very expensive to fly on the space station. And you want to make sure that you're delivering a payload that you really know is going to work. And a lot of people, almost everybody, goes through a process with parabolic aircraft, ZeroG time, to demonstrate and work out the kinks and the bugs in their experiment. And NASA very early on recognized that, yes, the doing it on suborbital flight is that sort of next step. It's twisting the words around a little bit. Not only is failure an option, it's actually a good thing. You want to wring out the bugs on a parabolic or suborbital flight before you spent all that effort to get to your one chance for your space station flight, right? So NASA was funding experiments on suborbital vehicles like Virgin and Blue, but only the experiments, not the experimenter. NASA was very nervous from a, frankly, from a legal perspective of, what's it going to be like if here we have funded a researcher to go into this very, potentially dangerous environment and something happens. That's not going to look good for NASA, right? Well, we all thought that was silly because, again, National Science Foundation and other places have funded people for years to go in Alvin down to the bottom of the ocean, right? That's also an alien and operationally, challenging environment. It's no different. And it took us a long time to convince NASA that, look, you're getting in your own way of your investigators' success. And finally, by last year, they kind of got that, and they finally, for the first time, approved that, yes, you can propose to NASA to not only, have your experiment funded to go fly on a suborbital flight, but we will actually also fly you as the experimenter with the experiment. And so last year, Alan Stern put in the proposal, and he was selected as the first NASA-funded experimenter to go fly on, in this case, Virgin Galactic, with our experiments. And we are now in the last stages of signing off on the contractual details with Virgin Galactic, and his flight will be coming up quite soon. I'm under NDA, so I can't tell you the details of exactly when, but it's going to be very soon. And so we will be flying that imaging system. The primary focus of Alan's flight will be to fly that imaging system and evaluate the window, the out the window performance of that camera and the Virgin Galactic windows themselves for out the window observations of stars and the Earth's limb and so on and so forth. How well do they actually perform? What about glints off of the aircraft itself and reflections off the internal reflections off the windows? How good a capability is that vehicle for doing out the window astronomy and aeronomy? And that's what Alan will be evaluating during the flight, along with the biomedical harness. So that's.
And I hope you don't
great.
get into a Starlink pattern.
What's that? Say again.
Man, I hope you don't get photobombed by a Starlink.
Oh yeah,
pattern.
yeah.
Oh.
Well, that would be I guess one interesting part of the evaluation. But no, I think it's it is what it is. It's we're going to focus actually, I think, more on bright object astronomy for these first observations, because it's going to be challenging enough just doing the first observations. And so I think we're going to be focusing on things like the Earth's limb, the sun, the moon, things like that. So yeah, it's the exact same system we flew both on the space shuttle and the F-18s. The Swiss flew on the space shuttle twice, imaging the moon, Comet Hale-Bopp, Jupiter, things like that. So a couple other bright stars. So we know it works. It's just that we want to make sure it works with a suborbital vehicle as well. Hey Norbert, see you waving.
Yeah, I had another question. I've got a good friend that built a power supply for an onboard ISS experiment making microgravity fiber optic cable.
Oh yeah. Oh, I
And,
wonder if that's. I just flew a ZeroG flight with a group of people that were doing fiber optic generation right there on the ZeroG, and they were getting it ready for an ISS flight.
That's probably the same group then.
Oh
he
yeah,
built
okay. I just flew with them a month ago back.
He repaired our power supply for our telescope and our observatory from his kitchen table, and here he is building this power supply for ISS.
Oh, okay. Yeah, it's the same. It's got to be the same team, because I don't know that anybody else is doing that. So yeah.
Yeah, probably. But are you familiar with how much more ISS stuff NASA is going to sanction, or are you up to date on?
I'm not really up to date on exactly what they're doing. I know that they're interested in maintaining it for as long as possible, right? I mean, obviously it's a very valuable facility, a very valuable resource, and nobody wants to chuck it, willy-nilly. That said, I think people recognize that there is going to have to come a time where it's not going to last forever. And already there are commercial companies that are beginning to develop their own commercial stations.
Okay.
I think it's public. I can mention, I think it's out there in the public that, for instance, Blue Origin, as one example, is developing something called the orbital reef. The idea being kind of like the Great Barrier Reef, right? It's the sort of, that boundary between the continent and the deep ocean. So you're out there doing it. But the idea there is a commercial entity to allow people to do not only, academic research oriented sort of things, but commercial operations as well, developing new products, new materials, new capabilities, 3D printing in space, all those kinds of things we can discuss that are, unique. And we're at the stage with all of this. I'll use the same analogy that Alan used years ago when we were first pitching the idea to Congress to be funding NASA to do this sort of stuff on suborbital research, on suborbital vehicles to do research. Is we're kind of at the stage with space applications of various commercial things, like we were with computers back in the 1970s, right? Imagine trying to tell somebody, like, what would you do with a computer in your home in 1970? And, I don't know, store your recipes, or something like that,
Old Zoom meetings.
Yeah, I mean, nobody in 1970 could imagine, but he just physically couldn't imagine having a computer in the home anyway. It would take up half your house for one thing, but then what would you even do with it? And, you know, nobody imagined the internet. Nobody imagined global, you know, knowledge base and, you know, GPS and, you know, smart lights in your home and, you know, just every 3D printing and every other capability that home computing, you're, you know, just, well, my phone's not near me, but you can pretend that's my phone, right? You know, having, you know, Star Trek capability in this little thing that we all carry around with us now. And nobody could have imagined that. And I think we're at that same stage with a lot of the sort of commercial applications of technologies and capabilities in space. We're only scratching the surface, and you know, some people are coming up with some pretty darn amazing and innovative stuff, but it's
the
only
general idea is that the space station is actually beginning to smell pretty bad from years of use. So how is the vomit comet?
It has an odor, but it's more, it's the difference is, if you've ever been on any military aircraft, it's the smell of utility, right? Every, you know, you hop on United Airlines flight or your Southwest flight, and they're meant to be a hopefully somewhat pleasant, you know, travel experience. And they're you know, you're sitting in comfy seats, and you've got a little, you know, drop down trays, and you've got your plug-ins for your phone, and you know, some of the older ones now have still got the little TV screens in the back of the seat in front of you, so you can watch movies and things like that. And there's, you know, nice comfortable lighting and the little air vents and things like that. Imagine stripping all of that out of a commercial airliner, the baggage compartments, the seats, everything, and then padding the interior. That's the inside of the 727, the 727-200 that ZeroG flies. And it's, you know, it smells of the jet fuel and, you know, the padding and things like that. I wouldn't call it a bad smell. It's just a different smell. It's a military smell. Doug, you were muted.
At least you have legroom.
Oh yeah, definitely. Definitely. Yeah, I encourage you to just go on the web and go on the ZeroG site and search around for some of the videos and things. You can see some of the types of things that folks have done over the years. It's an amazing thing. Go back and find the interview, find the video on YouTube of the immediately after William Shatner's flight, when he was talking to Jeff Bezos there on the ground, and listen to that 2 minutes of him in the moment right after the flight. And I think you'll get a good sense of why it is we do this, and what it's all about. That transformation. I think you've all heard of the overview effect, or many of you have heard of the overview effect, that change that seems to happen in just about every astronaut who's ever flown and seen the Earth from above. You know, I haven't seen it yet, so I'm only describing it, and it's fun for me to describe it this way, because this is almost exactly what Bill was trying to describe after his flight. That, you know, people have talked about the overview effect, and we kind of imagined what it's going to be, but he was speechless with tears in his eyes trying to describe the impact that flight had just had on him. And everybody we've seen walk off those vehicles has that same reaction. And I think when more than just 500 military test pilots have had that experience, when, you know, your neighbor down the street and people you know, and people everybody knows from various diverse backgrounds have gotten to have that experience, it's going to change a lot of things, I think, about the way people relate to each other. And that's the amazing beauty of this to me, right? It's not just about going up and getting a view of the Earth. It's about changing how people relate to each other. I think space flight and the view of the Earth and that overview effect and that change that it has and that change that it makes in people is what it's really all about. It's not about looking at the Earth. It's not about the technologies and the experiments and the things we learn. It's about how we as people interact with each other and how that will change when more and more and more people have had that experience.
If I don't want to monopolize question, but Dan, how high have you been in altitude and how deep have you gone?
Oh gosh. So if other people have had this kind of range of experience in their lives, I've done like this much in comparison, right? So anybody who's flown the Concorde has flown higher than I have. My highest flights in the Hornets were at 49,000 feet.
Okay.
It's enough to make the sky pretty darn dark. I'll tell you, I did some flights, 6 flights back in 2000 through 2002, specifically at twilight during the equinoxes to look for volcanoids, population of small objects possibly inside the orbit of Mercury. And we were, yeah, there you go, the overview fact, Jack. Good book to recommend.
Yes.
And the sky, I tell you, I have never seen the zodiacal light as bright as I have seen from 49,000 feet in the F-18. It was blazing in brightness, it seemed, and just absolutely amazing. And in depth, not that deep, a couple hundred feet for some of the cave dives and things I've done. When you're cave diving, when you're an open water diver, you're diving in the ocean on a reef. First of all, most of what you want to see is very shallow anyway. Quite frankly, when you're on vacation snorkeling in Hawaii, you're getting about as good a view of most things that you want to see anyway. You don't even need to go that deep. But when you're doing a cave dive, you have to go where the cave goes. And if that means going down to 300 feet, that's what you do to get through to the other places you have to go. And so it gets you into a very different type of technical diving where you have to manage your gas supply, manage your gas mixture. You are forced into decompression diving because of those depths and the time it takes. And so it's a very different type of diving. But that's what I liked about it. I haven't been doing it lately. There's not many places like that to dive in Colorado, and my priorities have moved on to other things I do. So I miss it a lot. Cave diving is incredible. And I love the challenge, the technical challenge, the managing of the information during a cave dive. It's closest thing to an EVA, an extravehicular activity that I can think of without going into space. It's not why I did it, but it was certainly running through my mind while I was doing it. I just love the technical aspect of cave diving like that. But
it's fascinating careers and stuff that you've done. I get sick going to the top of Pikes Peak, so that's off to you and where your range of destinations. Thank you.
So when you go up there, Dan, are they going to let you wear a Lowbrow t-shirt?
I will happily do that. I can wear and take anything I want with me. Yeah. So,
Ooh, cool.
All right.
Well, so I could wear it, I suppose. You won't see it because it's under a flight suit that we'll be wearing, but
So that's true.
yeah.
Well, just wear it on the outside of the flight suit.
Yeah, one could do that.
You know, we've got major corporations throwing stuff up into space, and Virgin Galactic talking about a permanent station, and the Chinese are doing stuff like that. Who's going to manage who gets what?
Yeah, well,
in terms of
that's the beauty of this, right? The more entities, the more countries that do it, the more commonplace it gets, and it's I don't know quite how to say it. I mean, the beauty of it will be that we don't have to make the choice about who gets to manage it. Everybody gets to manage it at that point, right? It becomes so commonplace that it belongs to everybody. And I think that's the goal we want to have. My way of looking at it is
some orbits that are better than others for doing various things.
Well, yeah, right. That's the other thing too, is it's not, I mean, competition is good in that sense, but this is not even about competition. It's just about variety and access to more and more different capabilities. It's about being able to pick and choose. I want to go to Flagstaff. Well, do I take a United flight? What about Southwest? It's nice having that choice. It's nice having the ability to match the capabilities of one provider with your needs and your wants.
Yeah. But in the end, the FAA decides who, what, where, when, and why, and how of all of that aircraft going to Flagstaff.
Well, yeah, right. Well, I'll say two things about that. One, so far at least, I think the FAA, and I've worked directly with some of the people in the FAA on this. They have been very, up till now at least, and so far, they have been extremely understanding and enabling of what it is we're about and what we want to do. And they've really
Yeah.
taken a sort of a hands-off, informed consent sort of way of thinking about it. I think they've done a very good job so far. That said, that's only within the United States, and there's no reason that, you know, people in Dubai or Brazil or Australia or New Zealand can't have their own program doing what they want to do. And that's the beauty of this, is there's no one entity controlling it. There shouldn't be one entity controlling it. It should belong.
Well,
It,
it's
you know,
not so much that, it's coming to a common agreement about how things are going to be done and managed so that you're not running into one another.
well, there's that. I mean, I guess with suborbital stuff, you won't be running into each other so much. But yeah, well, okay, certainly when it comes to orbital flight, then that's a different story, where you're going to have to manage the things so that we're not running into the, you know, some country maybe unnamed deciding, oh, we're going to blow up a satellite or run one satellite into another for a fun test and see what happens, and generating debris all over the place that's impacting everybody else. Yeah, that's we would like to be avoiding those kinds of things for sure.
You know if any of these, at least the near planned orbital facilities are going to be sort of like a second generation equivalent of LDEF?
Oh, even more than that. I mean, we're talking about actual space stations, not just for the experiments, but I can't tell you too much about designs that I've seen because I think they're proprietary, but you have seen things like inflatable space structures that can be launched and inflated into much bigger things than, you know.
Oh, you mean like the Bigelow stuff?
Like Bigelow and so on. There will be, yeah. So what we're talking about with these commercial, like Orbital Reef, for instance, it's not about just an LDEF with just slots of experiments. It's a full-on, honest to gosh, you know, human tended, you know, facility. So yeah, no, people are thinking big, and I don't mean just big physically. They're thinking big conceptually. You know, the people who are playing in these games are, you know, they grew up like we grew up with 2001, you know, and stuff like that. And I think people are thinking along those kinds of lines of, look, this is going to get to the point where it's, you know, it's just part of everyday life, flying in space and moving between the planets, and, you know, having a living, thriving, breathing, you know, quadrillions of US dollars economy in space is what people are thinking, right? I mean, and I use that number, you know, not willy-nilly. I mean, there's, you know, we're living on a little island and amongst an entire ocean of possibility out there, and that possibility is not just intellectually but economically as well. So yeah,
Dan,
go ahead.
For your recollection, this sort of qualifies as a freeze out, and we still have a variant of the artsy meaningless slideshow being presented. So I thought you'd be enjoy to hear that.
Oh, absolutely. That's cool. That's excellent.
Yeah, in December.
In December. Okay.
Yep, December meeting.
Oh, excellent.
So were you actually done, Dan? I didn't know if you were trying to.
Oh
spin
yeah,
up
I
that
was.
video or-
I was trying to see if I could find a movie or two. I hate to stumble through because while I'm looking, I have a hard time actually.
Oh, no problem.
Doing questions and stuff. But let me search through and see if I can find one or two of my little movies. I'd like to show you the Starfish movie. Oh, here it is. Okay. Now I'm going to go back to the thing here. I'm going to see if I can go back to share screen. Oh, yes, there we go. Okay, share. But now I got to back it back up. You guys are probably seeing some stuff happening.
Yep.
Oh, yay. Yep. Okay. So
All right.
this was our October 2020 flight. So here are this is two different views of the same little starfish. You can see our Bennu carbonaceous chondrite regolith floating around inside our little chamber there, and you see our little tetrahedron spacecraft. This is, fits in your hand. And you see all these little bits collecting on the magnets on the outside. Just look at the petals on the outside there. Look how all the material is just ganging up on those exterior magnets. Watch this thing float around on its own little internal timer. This is a completely self-contained little spacecraft. Inside is a little brain saying, okay, I've floated in zero G long enough along the surface. It's time now to extend my little pedals and run my little motors and invert and eat up all that regolith and contain it on the inside that I just collected. And I'll tell you, that thing collected 50% of its own mass in regolith sample. And that's what it'll look like on the surface of a small asteroid when it goes and does that someday. So very successful. It was a really great thing. Let me stop sharing. And there you go. That was the movie that was supposed to play during the talk that didn't.
Any other questions for Dan?
How would these starfish samples be collected? I mean, after the trap shuts.
Yeah, that's sort of the second and third phases of bore that we want to explore is getting them collected again. We envision carrying, like 50 or 100 of these things on a mother spacecraft, and then there are multiple little microsat, like CubeSat level payloads that have been demonstrating things like propulsion and power generation. The idea we have is that ultimately with a little homing beacon on each little spacecraft with their own little self-contained propulsion that will then hop off the surface to then be scooped up by the mother spacecraft and then brought back. I mean, conceptually, of course, obviously only at that level, demonstrating it and getting the individual bits and pieces of, how do you capture them on the mother spacecraft? How do you, grab a hold of them all? What's your loss percentage? Not every starfish is going to be successful. Not every starfish that gets back off the surface is going to be collected. But that's the beauty of the system. They're so small and so cheap to build that if you launch 50 of them and you get 10 of them back, you've still gotten 10 samples of the asteroid. So that's, who cares if you lose the other 40, right? They're so cheap and they're almost disposable anyway. So that's you don't have to put, $50 million into your one precious one-time sample. If it fails, you get nothing, right? It's better to spend $10,000 on 50 of these things and hope you get 10 of them back. So that's the goal. That's the goal.
Okay. Looks like maybe we've run out of questions.
Is SWI involved with the DART mission by chance? I haven't read much about that.
Yes, we are. I am on the scientific investigation team for DART. There are, I think, 3 other people in the Boulder office and 2 people down in the San Antonio office also on the investigation team. We are, in fact, just talking with one of my co-investigators today about our schedule to be back out at the NASA Ames gun to do more impact experiments directly related to helping predict, and interpret what the DART impact is going to be telling us in terms of momentum transfer and so on. So we'll be back out at the Ames gun in sometime this spring, summer to do more experiments directly related to that. So yeah, on the investigation team.
Color me amazed. Wow.
Speaking of impact, I just a couple days ago saw you on one of the Doomsday 10 Ways the World Will End series.
Oh yeah,
The asteroid impact.
Yeah,
that series is actually fun.
Yeah, there's a let's see now, is that the, I can't remember, is that the film noir version program? I can't remember. There's a program I did that I haven't seen yet that's kind of done like a film noir style of thing. I can't remember if that's the one.
No, this is more of a docudrama type.
Oh, okay. Yeah, I've done enough of these. I can't remember which ones are which. I don't really see many of them anymore. I get them. I do the I sort of do the editing level of review of these things after they're done, but then I oftentimes miss them on TV. But yeah. Fun stuff. Well, it's great. I'll being back with you all. Like I said, deep roots with the Lowbrows. I was an undergrad there and have extremely fond memories of all of Ann Arbor and my time there. And you know, Loudon's Astrofests on the third Friday night of every night over at Modern Languages building, and then doing
Jim Loudon.
doing our Lowbrow meetings at the Detroit Observatory. I don't know if they ever fixed the problem of all the cannonballs moving to the one side of the dome and having it tip over to the side, and you have to lift it and rearrange all the cannonballs again.
I don't know if you've been aware, but they've added a beautiful new addition for meetings and all kinds of stuff. The Bentley Historical Library, they've invested several $1 million in renovating the observatory, and that's why Charlie mentioned that the meetings could potentially be held back there, because it's
Great.
if you go on the webpage for the Detroit Observatory, you'll see the new addition. It's quite striking.
Well, you know, it'd be cool, Dan, is if we do move back over there and it just happens to work out when you're in town, it'd really be neat to have you do a presentation for us over there.
Oh, I would love
That'd be
that.
like good old times. Huh?
Yeah, it would definitely be like good old time. I'd love that. It's really funny too, because that was right up the hill. When I was an undergrad there, I roomed at Mary Markley Hall just down the hill. So for me, walking over, I just walked over from Mary Markley for the meetings. It was so fun.
Yeah, if you look at the webpage, you'll notice that they've invested a large sum of money in renovating the refractor telescope, the transit scope, and the facility itself. So you'll be impressed with what they're doing, and they're going to have a grand reopening in April, COVID permitting.
And I assume by renovation that means that they've done a very good job of preserving historically, as much structure and things as.
Yes, and then if you'll notice, they've added an addition onto it towards the dorms there on the south side, with an elevator even, and even a kitchen for holding meetings and that kind of stuff there at the observatory. But the integrity of the telescope and the transit especially are quite beautiful.
Beautiful. That's great. That's great. Well,
okay.
I appreciate the invite back. It was a lot of fun to be here again.
Same here. Thanks again, Dan. Till next time.
You all.
I think actually in our email communications there that I talked you into taking a gift certificate from us.
I would be very happy to do that. We'll talk offline about maybe picking a good restaurant gift card or something.
Okay, sounds good. That's what I was going to ask you. So
yeah, that sounds great.
Okay. I'll contact you about that later today or tomorrow or something.
Thank you very much.
Okay, cool. Excellent. Okay, so with that, we will move back to our continuation of the officers meeting. I was just talking about Cromaine Library. And I think when they were talking about, well, that was odd. Just had a sidebar pop up and I didn't touch anything. Anyway, they were talking about doing this event last summer and they never actually followed up on. Not sure what happened on their end, but we did have a couple of people. It might have been John Wallbank and maybe Doug Bach that said they might be able to do something there. Am I mistaken?
Oh, yeah, Charlie, I'm up in that neck of the woods. Yeah, they're a little bit difficult to communicate with sometimes, but if you keep in touch with me about that, I can get the information about what they're thinking about and see what's possible.
Okay, yeah, so I'll reply to his email, include you in there, so we can get you in loop there and figure out what we can do for them. That'd be cool.
Thank you.
Okay, thank you. That is actually all I had. We got an email from Joy this evening that she was not going to be able to make it. I think she said on her way home, and her daughter informed her they had lost internet and apparently thought Joy was going to fix it. So, and I see she hasn't joined us, so I'm guessing she's still offline. The only thing she had to report, just wanted to let us know that she had updated the calendar to show that this meeting was going to be Zoom only. Also, Liz was not able to attend, but she just wanted to let us know that almost all of the calendars and handbooks have been distributed, so she's almost done with that project. So with that, how about our hero taking the minutes for today, Dave?
Hey, Charlie. Well, I really don't have a whole lot to report either. Most of this has been on, emails and so on. But I think I should just say that thanks to you, Charlie, for getting two of our speakers, one in December for the Artsy Meaningless presentation, and also for January, Guy Cosmolano. So we're left with two open speaker slots, one in July and the second one in November. We've got a couple of ideas about it, but at this point, they still remain open. So, and I think it should, I think you've already mentioned it, that the September meeting has been canceled, and our speaker now, Nicole Zellner, will be participating in the Astronomy at the Beach event on the 16th and 17th. So that looks good.
Thank you, Dave. So we're really kind of just moving our meeting over to Astronomy at the Beach in a sense. But yeah, that was nice of Nicole to be willing to do that. So
yeah,
got us out of that little temporary jam. Anything else, Dave?
No, I'm all set.
Okay.
Thanks, Charlie.
All right, thank you much. Adrian. Oh, he left us someplace, I think. And I'm guessing that's because he's out of his car taking some images. So we'll catch up with him later. Amy.
Nothing to report this time.
Okay, thank you much. Jack.
Well, right now I'm going to see. All right. Now, what's our share screen look like? Do you
Not
see the
happening yet.
observatory?
No.
No? Ah, shoot. Darn it. Well,
I was gonna say I could give you co-host, but I don't think I have to
Nah.
do that for you to share a screen.
shouldn't have to.
Yeah, I don't think I have to.
Okay. Oh, my Zoom meeting came back up. No, that's not supposed
Hang
to
on, I
come
just
up.
made you a co-host just in case that was it.
All right. Sign in again? No. What is going on here? Yeah, something happened. Well, okay. Oh, well. Anyway. Can you see anything, or am I completely off the screen?
Completely, just see you.
You can see me?
Yeah.
Yeah, see and hear you fine.
Huh. Then do you see the observatory picture?
No.
No.
Yeah. Okay. Something happened here. I don't know what. But I can't this ain't gonna work out. I don't know what happened. I hit share screen and my Zoom came back, and I have to all re-sign in and all kinds of stuff going on. So you guys can hear me then?
Yes.
Yeah.
Okay, then here's what we'll do. I've been out to the observatory taking care of it. The humidity sensors and everything are working. The rest of the observatory is in pretty good shape, I think. The only other thing I can really think of is I'm kind of waiting till March for our open houses. And at that time in March. Oh, did everything just come back on? Because I'm seeing the meeting now.
No, we didn't see any change here. Oh, there you go.
Okay, yeah,
All right.
all right. I don't know who did that, but anyway, it seems to be okay now. Just give you an idea of the internals and that. Inside of the building looks pretty decent. We got everything taken care of. We're getting ready for opening up in March, depending on what happens with our COVID and university and everybody else. We'll take it from there. Hopefully it's maybe sometime in March or something. I would like to get a couple guys together again and go back and look out at the Sky Safari and the tracking on it, and get the Argo Navis and everything and check that out, set it up again like we used to have it. Other than that, that's all I have to report. We should be okay.
Okay, thank you, Jack.
Okay.
I hope we can do open houses pretty soon before I forget how to operate that sucker.
Yeah, what I'm getting ready for is open houses. I've done some work on it, just testing, right, as the RA and deck and making sure that works and stuff like that. So yeah, we're getting ready.
How's
Okay,
the
thank you,
road
Jack.
from a down tree and erosion standpoint?
Pardon?
How is the road from an erosion of the road surface and down tree kind of standpoint?
Okay, the road going up, they did that last year. I think it was the year before, but there hasn't been that much traffic on it. There's a few minor spots for ruts, but really it is still good traveling up. If you want to drive up there, I was just up there a few days ago, and it's still good. But the important point is there has not been a lot of traffic up there in the last couple of years. So once we get a lot of traffic going, by the end of 2022, yeah, they might be looking at resurfacing that dirt road going up there again. I don't know. It's just right now it's okay, but like I said, when the traffic comes back up there, that will change everything. As far as the rest of the area around there, the asphalt roads up there that go up from the radio observatory and that, those are fine. They still have the security system up there. Minor thing we might have to do is that 2-track dirt road going down the observatory. Probably in March, I'll have to go and just do some trimming around there because the trees growing overhead, limbs hang down when you're driving your car through there and stuff like that. I want to make it a little more open so when people walk down there, they'll have a little bit more room to walk in instead of just that walking inside the track on that 2-track dirt road. But other than that, that's about it.
Okay, thank you, Jack.
Okay.
Jeff, of course, had to leave the meeting, but he did send a chat just before he left to say that he's going to be setting up a communications committee meeting next month. And with that, the guy with our money, Doug.
Not much has changed since last month. 174 memberships, a little more money. We have $12,083.97. The only weird thing about that is the RASC still has not charged us for the handbooks. We still owe them hundreds of dollars for the handbooks, and every time I checked, and with their contacts, so I don't know what to do there. Wait, I guess, but they haven't charged us. And as far as expenses go, spent $9.20 to send a T-shirt to Don Foley for his December talk, which was excellent, by the way, and about $40 to Amy for printing and mailing the newsletter. in December and January. So that's where things stand. Not a lot different. My mail forwarding here to sunny Florida is finally working. Finally got the keys to the mailbox, and so it now takes about 2 weeks for things to get to me, whereas it was about 2 or 3 days to get it to Traverse City. So anyway, that's it. Not much else is new.
So when are you back
So-
in Michigan?
End of March, 1st of April, give or take a couple days.
So a little over $12,000. How much short are we, Dan, of getting a flight to on Virgin or a Blue Origin, sir?
Well,
Don't think
they,
12 will do it.
yeah, they just upped their prices quite a bit, unfortunately. Yeah, those are still, lucky enough to have mine paid for by the office, but
Yeah.
they're gonna set you back a few $100,000 these days.
Mhm.
Pardon me?
They're gonna
How
set
much
you
was
back
that?
a few $100,000. Yeah.
Oh, okay. I thought you said a few thousand for a minute. I was going to say, sign me up.
Yeah, me too.
Yeah. Well, that's what I was thinking. We probably needed about 10 times that amount to even think about it.
Well, remember though, this is flat screen TVs in the late 80s though. I remember going in and seeing these things, a relatively small one for $16,000, and it's like, yeah, well, gosh. But now they're $160, right? So it's going to be the same thing. It's going to be economy of scale. The more they fly, the cheaper it'll get.
Oh, one more thing, Dan and Charlie, keep me in the loop as far as the gift card.
Yeah,
obviously. So
yeah, we got it. Does anybody have anything else? Norm?
Me yet again, for Dan. Are you familiar with the fact that the exhibit museum was torn down and the new building replaced? They got a new high-tech planetarium in there. And the facility, it's in the same footprint as the old exhibit museum, but it's a whole brand new high-tech planetarium. And Matt Linke just recently retired. I don't know if you remember Matt Linke from many years.
No, I don't remember Matt, but yeah. Oh gosh, well, things change. It's been a while.
Yeah, you'll have to see that. Buddy Stark is the new director, for those of you that don't know. So he was a friend of Matt's, and he's on board running the planetarium now. And EMU has a planetarium. I don't know if you know that, but we have a sphere in our Mark Jefferson building. It's all renovated. So
Nice.
We've joined the planetarium club.
Good, very good, excellent.
Yep.
And actually, ironically, we've heard more from Matt since he's retired than when he was the planetarium director. He's actually become a little more active, at least in emails and stuff with the club. He's down in Adrian, as I recall. So he's going to, or Adrian or Tecumseh, I forget. But anyway, as soon as we do another event over at Hidden Lake Gardens, he said that he plans to be there because him and his wife are members there. So, but yeah, he's still kicking around. So
he's in Adrian, because I know I've got a student, and one of our instructors is Adrian planetarium director, and he's enjoying his fun play, his off time playing with the Adrian planetarium, which is an old Spitz AP3.
Oh wow, cool.
Yep.
Anybody else?
One thing, we got an Ask the Lowbrows inquiry about wheelchair access to observing opportunities. And I responded, but I really, didn't have much information to impart other than, some links to the various clubs. If anybody knows of any observing that's being done that's wheelchair accessible, for the general public, let us know and we'll pass it along.
Yeah, one thing with respect to that, regarding the university and the university's requirement for a disability access, the only disability access, of course, to our observatory at Beech Mountain is if a person drives down to the observatory. And generally, we don't recommend that once that we have opened the open house. So that may be something, a detail, a parenthetical detail that we need to address.
Yeah, you know, that's real money, and I don't think that it's anything we'll be able to take care of. I did tell them that the roof of Angel Hall, the Student Astronomical Society conducts Friday evening public observing up there, and that was accessible. But that's the only thing I know of for sure.
Just to bring up a point on that, in the past, we have had a couple of times where people in wheelchairs came out there, but they had somebody that was assisting them. I guess I'll call them a caregiver, and they helped them move that wheelchair up to that rock grading and that up to the observatory door, and we could roll them up into there. We used the same ramp that we built for the 17.5-inch, that little wood
Okay.
ramp in there. But still, that's only been a couple of people. If we were to get a group out there, I could see some problems with that, because if a group was coming out there, they would have to have at least someone there to help them, a caregiver or an assistant. And we'd have to kind of coordinate that, because there might be 6 or 7 of them at one time going in there or more. I don't know.
Yeah, well, if we know people are coming, we can set up telescopes on the road up top, and that would be, you know, people could just wheel their chairs up to and they could look through the eyepiece. But, you know, I think that's the extent of what we can practically do.
Yeah, it is difficult on the 24-inch because sitting in a wheelchair, the scopes has to be rotated almost directly where the eyepiece is pointed on the ground, like, and they can look in it, because we had most people do that. I do remember one person trying to stand up in his wheelchair and look through it. I don't really recommend that. I would rather have them sit, and then we'll move the scope down and we'll find overhead that they can look at.
Yeah.
How about cameras? Putting a camera in for the eyepiece and a viewing screen.
You could do that. You get the right kind of digital camera and then project it on your iPad, stuff like that.
I would think you might accumulate to get more light, but yeah.
That's one way of doing it. It's starting to get popular.
Yep.
Yeah, we've talked a little bit about electronically assisted and using the back outside wall of the observatory for a screen.
Yep.
Yeah, that's true. Matter of fact, I think Brian Odom has a program he was doing that with, where he was doing observing with his telescope and then projecting it on a screen. He had talked to me a long time ago, but that was before, well, that was when the COVID-19 came in and we kind of closed up the observatory.
Yeah, he was doing that last year, and he had some impressive results. He was using an 80mm scope so that he'd have a wide field, and he was able to project the North American Nebula and the Pelican and all that kind of stuff. So I thought it was fairly impressive.
Yeah. Well, and that we could work something out like that, maybe with a group.
You know, we could put a scope that could ride on the McMath that would have a wide field.
Yeah, there you go.
You know,
I have a Celestron 8-inch Raza scope that's ideal for that kind of stuff with the ZWO color cam and a go-to mount. It's a beautiful. It's perfect for EAA astronomy.
So where did you say you say you store this scope, Norbert?
Scherzer Observatory. The OTA is only set $1,800, so I mean, that's in your budget.
Yeah, it's something we should seriously consider.
Yeah,
it's perfect for that. I mean, it's an F2 system.
Yeah.
So what with the camera, it's about $4,000.
Yeah, probably. but the OTA is nice and light, and it's a beautiful instrument. I just got an electronic focuser for it, and once the January weather thaws a little bit, I'm going to be doing more live stuff for my labs up there in Scherzer for it.
think
I have
some
that
of us
choice
have-
or the Williams Optics refractor that I have for a little more horsepower, but that 8-inch Raza gets a very nice wide field.
Well, I think the club ought to seriously consider putting together a system and, and if you get something together, we'd certainly want to come and look at it.
Yeah, well, it's up in Scherzer Observatory if you want to see it, and one of the rare scopes that's actually in stock these days. I see them there in stock.
Okay.
The only thing I can see is a little bit of a challenge there is usually we're targeting the 24-inch on more narrow field objects. We're not using it for wide field.
Yeah.
So that'd be the only thing to
Yeah.
think about then is how much is that wide field going to capture what the 24 is looking at?
Yeah.
That's something to think about anyway.
Well, if
But
we,
yeah.
if we pointed the 24 at an object, say like the lagoon, that would come up pretty well on a
Yeah.
wide field, with the Triffid would
Mhm.
be there and all that stuff.
That's true. Yeah. Yeah, you're right. There'd just be
There
some
are
select
objects
objects
of
that definitely
opportunity
would
like
work.
that.
Right. Yeah, great.
Or if we went to, in the fall to the Andromeda Galaxy, we've certainly done that with the 24 and shown the core, and we get a great wide field of that.
Yeah.
That's true.
Yeah,
Well, there-
Charlie, I'll send you, Joe Brusso and I were running it up at Fish Lake, the Raza, and I can show you the star. I'll send it to you so you can figure
Okay,
out what you
excellent.
want to do. So
Yeah,
but I
that'll give
got
us something to start.
it
Oh.
basically would cover the whole sort of Orion, that region, Horsehead. Then Andromeda Galaxy is beautiful in it. I mean, 1 minute exposure, which you can just integrate and do live with EAA even. It was as good a picture of the Andromeda Galaxy as I've ever taken. It's really a nice system.
Yeah, it'd be cool if you could send that to me. That would be something we could use to get the conversation going about maybe doing so. I think it's a great idea.
Will do.
Okay, cool. Thank you. Anybody have anything else?
Yeah, just one more thing on that,
Mhm.
that we need to think about. With these systems, especially using a Peach Mountain, everybody's night vision gets blown out, and then they've got the, we do have to come up with some protocols on people readapting so that they don't fall all over the place, because it's rough ground out there that we can't do anything about.
Yeah, you're right. Got to do some thinking on that part. Yeah. Maybe we have them look at objects in the observatory first, and then we turn on the video on the outside wall as they're leaving. Take them
Jack,
out at the last minute.
is there wireless internet yet up there in that building?
No.
Okay.
The most they have is there is a Starlink setup on the small building across from the radio observatory. Professor Cutler has one set up there. It's outside the building on top, and you can see the dish that he has there. And that's the only one up there, really. They did not get into the more advanced concept of bringing the fiber cable there. That got to be extremely expensive, and I don't think they're going to do that. So the Starlink is the only one up there.
So any idea how well that Starlink is working?
I personally don't know. Maybe sometime we get Professor Cutler to tell us what his up and down is. At one time, he talked to me about it. At one time, some of you remember when we were doing a Zoom meeting a couple of years ago, I did go out at the observatory with my car, and I had I bought that, it's an OnStar unit.
I remember that, yeah.
Yeah, and
Yeah.
I bought the extra service that comes with it, but still, it did not work that well. If you remember, we had some bandwidth problems. There
Yeah,
were some things that I
That's
could
true.
not see on the screen and that, so we need something that is a lot better. Something that is a lot more
well, if they deploy
up-to-date,
5G
powerful.
around here, that might do it.
Well, they've updated stuff like that. I have a Sprint drive, which is now T-Mobile, and it has a hotspot availability to it. So if somebody had something like that and unlimited data, it it would function up there probably.
Yeah, it's one thing we need to probably come up and test. Somebody has, we could test it one night, see how well things work up there with it. But that's all I know of it, really. I mean,
Well,
it just did not go any farther, and I have not received any other updates or information on renewing it. So I think that Starlink was the answer to what they wanted to do. I just don't think the money
Yeah.
was there to
So-
spend for all that.
Norbert, you've got this hotspot and the unlimited data.
Yeah, well, I mention it only because it's probably more recent than what Jack was using, some time back, and now it's, with 5G coming
Mhm.
online and stuff.
Yeah.
It'd probably work or function well enough to transmit the big images that you generate with the EAA. So it's all this nice high and dry tech stuff that I'm sure everybody's excited about hearing about. So, but there is some new technology coming online that might make some of this stuff actually possible.
Sounds like we could actually afford to get our own account and do it.
Yeah, that's what I was gonna suggest, but it's not thousands of dollars, it's hundreds of dollars.
Yeah,
Yeah, the other thing to realize though is the 5G, I mean, out there, you'd have to have 5G available, I think.
Yeah.
Otherwise, I think your 4G under bandwidth just isn't there for hotspots and that kind of thing. So we'd have to test it first, but yeah, we could create an account and have our own
Yeah.
potentially.
Okay. Anything else? All right. Do I hear a motion to adjourn?
Motion to adjourn.
second.
Okay,
Third.
we have a motion and support. I don't think I'm going to hear any objections. So with that, motion carried, and we are concluding the meeting at 9:20.
All right.
Thank you very much, everybody. Have a
Yeah,
good
good night,
weekend.
everyone.
Okay,
Bye.
thank you. Stay warm.
Oh, no.
No problem.
Yeah, no problem for you.
All right.
Yeah.
Not sorry. See ya.
Yep.
Okay.
Thanks, Charlie.
Thank you all.
Here we go. Good night.